Ladies and gentlemen, thank you for joining today. This is your host Nino, inviting you once again to an adventure with the beautiful French Minitel. And in this case, we shall be establishing a sort of setup where we are using an iPhone as a mainframe of sorts, and we shall be accessing some command line functionality on it via the French Minitel. Now, let's go at this step by step. It is a bit of a involved experiment, but actually rather simple if you have all the puzzle pieces together, which I shall do my best to provide to you in an effortless way. Links to the source and the commands you can expect in the description of this video, and I shall do my best to explain things here as we go along. So what do we want to do? You know, many times people are showing you how they have connected an old terminal to their Linux machine and how they can control the Linux machine through that serial terminal. With an iPhone, the situation is somewhat more involved because despite having a USB-C port nowadays, it does not actually permit you to access any serial port functionality on it. Android in a limited fashion does, iPhone does not do at all. So what to do? Well, find an environment called ish for I shall, a regular thing I'm using in my iPhone experiments here. Yeah, that's what it looks like. So it is simply in the Apple App Store, no side loading, no nothing, a harmless thing, an i386 Linux environment, which once you start it up, okay, it's erroring out a bit on me because I did some things with it, but the general idea is this is simply a virtual machine running Linux on the iPhone, and that's what we shall be accessing, and that is what we shall be using via the terminal. The ish environment is nice insofar as it is having absolutely normal network accessibility. It can act both in the role of client and of server, so you can run both a netcat or socat listener as well as a client on it. The connection between the terminal and the phone will be established via an ESP board that is a clone of the Wemos D1R32 that you find this way also in the famous Arduino IDE, by means of which I have programmed this board. Now, this board has the property of providing both a serial connection via its RX and TX pins, and thereby offers me a possibility to connect to the serial port connector on the back of the terminal, as well as having Wi-Fi functionality, thereby establishing a connection to the phone. So Wi-Fi translated to serial and vice versa is allowing these two devices to communicate. The Minitel, you have to be careful which model you pick, is having a serial connector at the back. However, it is a DIN5 looking connector. I'm not an expert exactly in these differences between DIN5, DIN6 and whatnot, but it has got 5 pins. And basically, if these are like your pins, the center one is ground, whereas the two ones on the edges are RX and TX. And to that purpose, I have created, it's a female port, these somewhat fatter wires ready to be plugged in with color coding so I know what I'm doing where. Now, there are two ways to basically conduct the experiment. The one method is that the phone is acting as a Wi-Fi server, like as a hotspot. So you turn on the hotspot mode, you connect with the board to it, and the board is providing serial, and then you can use the terminal in order to access everything through the phone, and the phone is accessing also the network. Very charming though, I found also the reverse fashion, which we shall try in fact first, that the board itself is creating a Wi-Fi hotspot evidently thereby, however, not being connected to the internet in any other fashion. So the whole thing becomes an island system and isolated from everything else. But once it has done so, the phone can connect out, so it does not accept a connection, it just simply goes out with one and provides a shell, for instance, via netcat. So it is connecting to the board and telling, hey, here is the shell, like let's chat, but chat with the shell. And you are seeing the letters incoming here, and if you answer, it goes to the phone. In fact, I did another ping pong step to that. So I'm not only connecting to the board, but also creating a little internal connection. This second little internal connection is necessary in order to give you terminal control. Otherwise, you will be having letters and you can chat, but you don't have a working backspace key, which is incredibly annoying. And you cannot set one, because if you try to use STTY, then it starts crying, hey, this is not a terminal. So in order to make it a terminal, there is also, so to say, a second connection towards the phone. If it does that, what it is right now doing, that is becoming dark and turning off its screen, beware, because that totally will interrupt your connection. Now, let me just show you the basic commands. I'm picking here the more complex version. That is, the board is the server, the phone is connecting to the board with a reverse shell. And let me show you what this looks like. I'm sure you would come up with something perhaps even better, but that saves you some search. So we are using BusyBox. I love BusyBox. BusyBox contains netcat. Netcat is going towards the IP address of the board. Like the board has created a Wi-Fi hotspot, we have connected to the Wi-Fi hotspot, we can now connect to the internal IP address of the board at a traditional port 8088, of course in honor of the 16/somewhat 8-bitish processor of the 1980s. We are then executing an unbuffering command so that things do not wait for end of stream signals. Like this is the standard buffer with E0 and O0. That means like just no buffer. Keep everything character level. And then we are executing sh, the shell. You could say actually that so far things would be sufficient. The shell and that's it. And that would be a possible way to have a reverse shell, yes. But I told you, no terminal control. So instead of that, we're saying the shell shall execute a command. And that command is a socat listener, which most importantly has this element of PTY, which creates virtual terminal and allows you to connect then to localhost on 8086, which is exactly the port to which socat is listening. But this time you will have a backspace key. In normal circumstances, if you're having issues with setting your backspace key, you can use also the setting STTY erase and then Control V, which means accept the next character printed just as a literal character. And then you press, for instance, Control H in order to say that backspace shall be Control H, a very traditional value. That is all a bit of a interesting topic here, because the Minitel terminal does not actually have any backspace key. Like up there I see nothing, and these buttons up there do not seem to work the way I expect. So they seem to be more oriented towards the video text operation rather than towards normal ASCII terminal usage. But if you press here Control H, you can totally use that as backspace. Not a major inconvenience. Should you decide to not use ish, the iShell on iOS, but to use the Termux environment on Android, you can do exactly what I have shown you. Or you can use, instead of socat, like the upper part being the same, a telnet server. So you're just simply starting a local telnet server and connecting to localhost 8086. Despite the telnet server being available also for ish on the iPhone, it still demands a login and cannot execute it. It is super frustrating. So this is why I really recommend SoCat for both. This will certainly work. And before we go into the nitty-gritty details, just one further word concerning the second experiment, which will be simpler. That is when the iPhone is having its own hotspot and not connecting to the board's hotspot, so to say. So just the board connects to the iPhone. Then we will be not needing any of the reverse shell mambo jumbo. We will be just doing these two lines here. Essentially, SoCat will simply have a listener on port 8086. And yeah, that's where ultimately the Minicom will connect to. Before we begin the actual experiment, let's just have a very brief look at the board I'm using. So this is a clone of the Wemos D1R32 board, which in this sense you will find also in the Arduino IDE among the ESP boards. And here I have connected a battery clip, a 9-volt battery clip to Win and ground, as well as having connected here RX and TX and ground, which I have attributed little flags. And these same flags are reflected throughout the connections down to the point where I plug them into the Minitel. Having this sort of color code, of course, prevents misunderstandings when plugging in things. And as to the connection itself, I'm using here slightly larger than 1 millimeter in diameter wire. Right, I'm not sure you can see that. I just simply scraped off here the header. And this fatter wire I'm plugging in at the back of the Minitel, where there is a small DIN5-like looking connector. But I have connected that to a thinner, more flexible wire, which then in turn really finally reaches over jump wires the board. So having some flexibility here to not strain things physically all too much. That turns out to be a rather good setup that I can recommend. If you're curious exactly how the connection to the Minitel looks like, here on the back, behind such a little cover, as you can see, there is its DIN5 looking serial connection. Some say it is DIN5, others say not really. And essentially there are 5 holes here. The center one is where ground is, and left and right are RX and TX. Don't worry if you don't get them straight the first time. I mean, then just simply switch the connections. It's just important that you remember to put the ground connection to the center hole. And now, enough of the great theory. Let us advance towards demonstration of possibilities. Let us start today's endeavor by first connecting to the Minitel via a reverse shell. In this effort, the ESP32 board will be acting as server. It will be the iPhone that connects to that server and from there connects back to itself, with the purpose of the back connection to give some form of terminal control, because otherwise things have a tendency to look terribly ugly. So to this end, I am now looking here for the wireless of the board, which of course I'm not yet finding because, haha, I need to connect our friend here to electricity. Now that it is under electricity, I am having here my Minitel network, to which I have now connected very well. And I can now turn on also the Minitel itself. We don't see its greeting print, so I will briefly restart the board. A feature which I implemented, which I find rather useful, is to let the Minitel greet you with a screen that actually tells you what is the expected reverse shell command, so that there are no surprises regarding what you need to type in ish on your phone in order to get there. So now in ish itself, that command which you're seeing here, we are triggering. All right, so there it is. I'll also give it an ampersand at the end. Now, enter. Address is already in use. But here it looks like things are generally working. Yeah, they are working, but the terminal is presently in its video text mode, which, as you can see, is not terribly helpful for using Unixoids. And I tell you, you may try to use it in video text mode. It's cute, it's bright, and I definitely prefer it that way for microcontroller experiments. But I find it really better to indeed switch it to its ASCII mode, or ASCII apparently, as some people are saying. And that is happening via function T A. And now pay attention, when I press A, this will become smaller, but also less bright. So now we are in this mode, and I can say PWD, but everything is being printed double. So because I'm having an extra echo from the terminal, this is turned off via function TE. And if I now say PWD, everything is normal. The advantage of this mode is also that you don't have to fight with the default uppercase characters of the other mode and so on and so forth. And even our backspace key is working nicely, which is Control H. Right, and if I say PWD, then it works. Should you ever have some issues with it, you could say always STTY erase. And then you're saying Control V, Control H, and then enter. Okay, here it somehow doesn't like me doing this, but anyway, we're having a normal one and I don't need to bother about setting it up, but that would be the way to set it up. Okay, what can we do here? What can we not do here? We can run programs. We cannot reach the net. At least not in any simple and obvious way. The reason why we cannot reach the net is that the iPhone is now connected to the board, and the board is not connected to the outside world at all. So this is where our connection ends. Yes, it does mirror it back in order to get you logged in with some terminal functionality, but it does not reach to anywhere. So that's why if I now say ping 1111, I'm getting nowhere. All right. And I'm not even sure that I can easily turn off ping, but then there's always the possibility to p-kill it. Ha. It's lovely to have this separate session running here. So you see, the outer world is taboo to us. What we can absolutely do, and I find actually rather neat to do it over the simpler BusyBox variant. BusyBox is to edit stuff with VI. We totally can. And as opposed to Vim, this does not have any of these ANSI escape sequences and other stuff clobbering your screen. It's just a simple VI environment. If I now press I to insert, I can say hello there, comma, apostrophe, okay. Control H. My dear viewers, one does need a little bit to get used to in order to get the hang of AZERTY on this particular keyboard, where everything is somehow squeezed, shifted, and sparse. But you can see, like, I can write in VI things. I'm just simply going to escape and quit without saving. Great, I'm back in localhost. I can say what sort of files have I got here. And you see the listing being built up, not exactly in a hurry. I can, of course, run some nice programming environments, such as embeddable common Lisp. And theoretically, I could now use my mainframe for computing Lispy things, such as, I don't know, 7 minus 74. Yeah. And so on and so forth. So you can see one can in fact use the phone absolutely like some sort of antique Unix machine, even with some more comfortable, more modern programs. You do lack up and down arrow keys. But in general terms, it is a nice and usable environment. We can start, I think, also the Midnight Commander. We can try to start the Midnight Commander, but the way I see it, that's not running exactly very well. Oh my god. So, okay, we are having an issue that we do not really have drawing characters, though I have never seen in such detail how Midnight Commander exactly is drawing the screen. Oh my god, that's terrible. No, I just want out of here. Forget what I said, Midnight Commander is a terrible idea. Escape Zero should get me out. Yeah. Oh, I'm so happy not to be in Midnight Commander. I can see whatever processes are running and things like that. So, yeah, if you ever wanted to experience your iPhone in a more mainframey way, then definitely the Minitel offers that possibility. And despite these limitations, this mode has some advantages. Think of it this way. You do not need to hard code into any board the network name and password for your hotspot, and you can change these any way you like. You could gift the board and just the data wouldn't change, you know, the access fashion would always remain the same. If you show it to kids, it's not terribly likely that they will immediately expose you to the internet, and so on and so forth. So yeah, this is perhaps a little bit rudimentary being so localized, but when you think of early Unix, these machines were very often not networked. So that's realistic, right? And having now handled this part, let's progress to the next one, where we access the phone as a server and the board as a client, as opposed to the situation we presently have. And now to the second part of today's adventure, we shall try to access the site of the BBC through the Minitel on the iPhone with the ESP32 board acting as a client. Here the advantage being, as the phone is acting purely as a server, so there's no reverse shell or anything, that you just can use the wireless of the cell phone, no further discussions taking place. Now the first thing you need to do is to turn on this funny hotspot thing and be on that screen for that board to connect, because otherwise, you know, it will be this way that the hotspot goes somehow into background and the board for some reason cannot find it. All right, so turning on the Minitel itself. Now let's connect the board to electricity. And we're getting here a little bit of a message also concerning the command which to run, and a bit of complaints that it cannot connect to the server, but it has connected already to the Wi-Fi hotspot, as is visible here on my phone's upper space in the screen. Okay, going now over to ish, the I shell, I'm going to issue this socat command, which is basically the same thing that you saw in the reverse shell, only this time it's not a reverse shell, it's just a socat listener. No big deal. Okay, pressing enter on that. And here you can see this localhost thing. But we are, of course, still facing the circumstance that we are in video text mode on the Minitel instead of the ASCII terminal mode. In order to change modes, we're doing again function T, A for ASCII, very good. And then also function TE to toggle the echo. And if we do some harmless command here just to see is everything going smoothly, like PWD, then yes, everything is. We even have backspace, like if I write PWD, Control HD, it will still execute PWD. So now we are in the iPhone and we're looking at the world through the Minitel, but now we also have network access to the outer world. So if we were to say links, the famous text-only browser, links bbc.com, then that will take a bit of an eternity, and you will see this cursor flashing across the screen, filling everything with spaces. And then we will see how links is connecting to the outer world, how it is building up things. And the speed of this is not exactly stunning. So if I were to say space, for instance, in order to advance a page, you see, this normally in a terminal nowadays is a momentary operation. Here, that's not entirely the case. You see things being built up as in a greeting from the 1980s. So, yeah, it is always marked where you can be going to. If I just follow this, I can press just enter for Australia and Pacific. Navigating is a little harder because we don't have cursor keys. We merely have, keyboard combinations like Control P for going back, Control N for going forward, I believe. Yeah, this is like going one line up, but it has to repaint all the other lines. You see, this is just getting a line down, and man, it takes its sweet time. So if we then, let's say, want to follow the link towards innovation, I can now press enter, and it will be building up now the BBC Innovation, Health and Environment page, and then we could scroll down and read news. Anyway, as you entertain yourself that way, just pay attention that the iPhone does not fall asleep. For if it does, then everything will end, things will crash a little bit. It's not a big tragedy, but you need to reconnect. I mean, I can simulate that by simply turning it off. And there we see already the microcontroller board complaining, cannot connect to server, right? Because this thing went to sleep simply, and I will need to re-establish the connection now. You can see what happens then, like this is basically socat having crashed. Okay, let's do that again. So we're back in the connection. We're having again our localhost prompt, though evidently the links browsing session is gone. I can say clear and clean up my terminal. And again, I would be ready for another adventure. And of course, once one is done, one can say simply exit. Can I though? Yeah, there was this super funny property of ish, the I shell, that once you type exit, you simply immediately re-enter it. So yeah, okay, I say exit and back I am. No big deal. Still, we can, turn things off the brutal way. There's always this possibility, of course. And that's it with our connection. But I hope you enjoyed today's adventure, at the end of which we have herewith arrived. And I hope to greet you here soon again for others. If not a subscriber yet, kindly consider joining our curious and friendly community. Until we meet again, I'm wishing you a wonderful time. See you hopefully soon. Thank you for watching, and goodbye.